Good day to all, dear subscribers and viewers of the channel. Vitaly Sokolov with you. Today we are going to talk about a free game engine that can be mastered in a fairly short time. And you can customize and display some three-dimensional primitives without a single line of code, using components on the form and their properties. But before we get started, don't forget to subscribe to the channel, place your thumb up or down under the video, and hit the bell to hear when new videos are released on the channel. And in the comments you can ask all your questions. GLScene. It is a game engine focused on creating 3D games. If desired, you can create 2D games on it. The development of this engine began in 1997. The original developer of this engine was Mike Lischka, then from 2000 to 2005 it was developed by Eric Grange, then the GLS team is engaged in the development of the engine. The game engine is still being updated and developed. But the activity in social groups, forums and websites on it has significantly decreased. This engine is licensed under the Mozilla Public License 2.0. That is, the use of this engine is absolutely free, even when creating commercial projects. The open source code of the engine is also available, which allows you to fix bugs and modify this engine to fit your needs. GLScene is a large set of VCL components that allow you to quickly and easily create multimedia applications. Working with graphics is based on working with the OpenGl multiplatform library. The following operating systems are currently supported: Windows, Linux and macOS. Initially, GLScene only supported the Delphi programming environment, starting with older versions from Borland. Now there is support for C++ Builder, Kylix, Delphi, free Pascal and Lazarus. The following 3D models are supported and loaded: 3ds, OBJF, vrml, SMD, MD2, MD3, NMF, October, LU, B3D, GL2, GLS, GLSM, MS3D, Nurbs, LOD, STL, TIN, PLY and some other. Next, I propose to consider the main features of this library. The main components in this engine are as follows. Tgl camera object. This is the point from which one looks at the three-dimensional world from different angles. Tgl Scene Viewer is an object for rendering the three-dimensional world. This is a playable character. To look on his behalf, you need to attach a camera to him. Tgl DummyCube, an object with which you can build complex structures. Tgl Material Library. The materials contained in it are transferred to the video memory of the video card. Tgl Freeform is a static 3D model. Used to load, for example, buildings, landscapes, trees and other similar objects. Tgl Actor, 3D model with animation. Used to load models of people, monsters, and other moving objects. Tgl Points allows you to draw points on the screen. You need to add points to the positions list. Tgl Lines allows you to draw lines and splines. Lines are defined by points, which can be added to the nodes list using the nodes add procedure. Tgl Light Source is a light source that illuminates the entire 3D scene. There can be a maximum of 8 in OpenGl. Therefore, there are also 8 of them in GLScene. Tgl Sprite, rectangle, by default, a square, always rotated to the camera. The main properties of the components. Position, the position of the object. Default, 0, 0, 0. Direction, the vector of the direction of the object. The default is 0, 0, 1. Up, the vector of the top of the object. The default is 0, 1, 0. Scale, vector of scale. The default is 1, 1, 1. Pitch angle, rotation of an object around the x-axis by Euler angles. The default is 0. Turn angle, rotation of an object around y by Euler angles. The default is 0. Roll angle, rotation of an object around the z-axis by Euler angles. The default is 0. Visible, the visibility of the object in the scene. The default is true. Show axis, show the axis of the object. 3 multicolored, mutually perpendicular lines. False by default. Normals, how to display normals. NS none, nothing. NS smooth, smooth. That is, 4 common points of several triangles, one common normal is calculated. NS flat, no anti-aliasing, sharp edges. That is, usually according to the principle of one triangle, one normal. The default is NS smooth. Normal direction, the direction of the object's normals. ND outside, outward. ND inside, inside. The object is, as it were, turned inside out. The default is ND inside. Primitives in GLScene. Tgl cube, parallelepiped, by default, cube. The cube parts cube property allows you to hide or show its sides. The cube size cube property sets the size of the sides, can be adjusted via the size property. Tgl sphere, sphere, default, or spheroid. Has a radius. If you change its size property, you can turn the sphere into a spheroid. The slices and stacks properties allow you to set the number of segments that the sphere consists of. The more, the better the quality, and the slower the rendering. Top, bottom properties, start, stop, allow you to cut segments from the sphere, specifying the cut angles. The cap type property allows you to change the display of the clipped caps of the sphere. They may be absent, disks, or cones converging in the center of the sphere. Tgl plane, plane, rectangle, square by default. It can be sized in the width, height properties. But you can use the size property that is common to the bulk of GLScene objects instead. Tgl disk is a disk made up of many triangles. The slices property sets the number of disk segments. Loops, the number of elements in the segment. The outer radius and inner radius properties define the inner and outer radii of the disk. The start angle and f-sweep angle properties set the starting and ending angles. Tgl cylinder, cylinder. Its slices and stacks properties determine how many segments it should consist of. The parts property determines which parts of it should be displayed, top, bottom, middle. The bottom radius and top radius properties set its top and bottom radii. Tgl frustrum, pyramid, by default, truncated, no top. The apex height property sets the height of the pyramid. Base depth and base width are the sizes of its base and the height property determines at what height the pyramid should trim the top. It must be less than or equal to apex height. The parts property determines which sides of the pyramid to show and which not. Tgl cone is a cone. Bottom radius is its bottom radius. Slices and stacks determine the number of segments that the tapered portion should be composed of. Loops, how many segments should be in the bottom. The parts parameter allows you to show or hide individual parts of the cone, tapered part, bottom. Tgl dodecahedron is a dodecahedron. Consists of 12 pentagons. Tgl icosahedron, icosahedron, 20-sided. Consists of 20 triangles. Tgl arrow line, arrow. Directed along the direction vector. The parts property allows you to show or hide an arrow at one end, an arrow at the other end, and the middle of an arrow. The top arrowhead height and top arrowhead radius properties allow you to set the length and radius of the cone of the arrow directed in the direction. The bottom arrowhead height and bottom arrowhead radius properties allow you to set the length and radius of the cone of the arrow directed against the direction. The arrow is convenient for indicating the direction of movement or the position of an object. Tgl torus, torus, donut. The major radius and minor radius properties define its large and small radii. Small is half the thickness of the torus, large is, so to speak, half the size of the donut hole plus half its thickness. The sides and rings properties determine how many segments the torus should consist of. Let's consider the main features of the scene. Hierarchical structure with many objects, the number depends on the REM, and ease of expansion. Interactive scene management, numerous Delphi experts. Simple rotation and movement functions for each object. Predefined objects, all standard from cube to teapot and sprites, easily extensible. Structural objects, wireframe, proxy object, for managing composite objects. Procedural objects, height field, rotation of solids, pipes, tessellators. Support for 2D and 1D objects, sprites, lines with spline support, is fully integrated. HUD objects, sprites rendered in 2D coordinates. Utility objects, grids, sky, arrows. Support for classes for direct access to OpenGl. Camera and light objects can be used anywhere in the scene object hierarchy. Behavioral objects can be attached to objects to animate them, expandable. Special effects on the object, before, after rendering the object and the scene, with the possibility of simple expansion. Support for particle systems, any objects or object structures can act as particles. Import of 3D Studio files with automatic calculation of normal vectors, using the given asterisk smoothing groups of the file, and texture coordinates. In addition, there are built-in capabilities for working with materials. Easy to use, streamlined, material objects. Library of materials for sharing. Light support, ambient, diffuse, emitted, reflected and luminous. Support for blending modes, transparency, blending. Auto-generation of the alpha channel. Support for OpenGl texture formats including compression, DXT, S3TC, etc. General support for shaders. High-level support for CG shader classes. Polymorphic images for texturing, allows you to use many formats as well as procedural textures, with a simple extension. More than 150 predefined colors such as CLR Cornflower Blue or CLR Cool Copper, easily extensible, in addition to standard colors and direct use of the RGBA specification. Easy use of moving and scaling text properties tour, regardless of texture coordinates. Support for 32-bit raster classes. In terms of visualization, the following options are available. Automatic use of OpenGl hardware capabilities, if available. Use with camera model, focus, distance and target. Multiple viewpoints for one or more scenes, easy view change through camera selection. Support for fog and depth of view. Rendering to a file in the form of a raster image or to a printer in any color and resolution. Support for full screen mode with dynamic resolution change. Reflection and mirror effects. Dynamic shadows. High performance support for transparent particle system throughout the scene. Automatic frustum culling, hierarchical or per object. When working with animation, the following options are available. Propagation of time progression events. Skeletal animation, lots of bones on top. Frame interpolation and morphing targets. Simple extensible behavior. Dynamics, inertia, acceleration, damping and force application. Automatic scene modulation. The graphics engine has the ability to work with the interface. Simple functions for identifying selected objects. Auxiliary functions for moving the camera, moving selected objects, converting screen coordinates to world coordinates. Utilities. Optimize geometric functions and utilities, vector, quaternion and matrices. Support for cubic spline and class functions. Mesh manipulation and optimization, stripification, vertex cache awareness, etc. Component for creating full-fledged screensavers in a few clicks. Accurate determination of the frame rate. Asynchronous timer, multi-threaded. Joystick support. Asynchronous keyboard access and support for layouts. GLScene supports work with physics through built-in engines, ODE, Newton game dynamics. There is also a small proprietary engine for calculating collisions taking into account the laws of conservation of momentum DCE. Despite a number of advantages, this game engine also has disadvantages that you need to be aware of. GLScene does not support mobile, console, VR, AR and some computer platforms. Because of this, the use of this engine is rather limited. There are very few video lessons and text guides on working with the engine, and those that exist are outdated long ago. Demo projects from the developers of the engine are supplied with the game engine, and custom projects are available for download in a separate collection. But be prepared for the fact that some demo projects can knock out errors and refuse to compile. The reasons may be an incorrectly installed engine, its installation has a number of nuances and sometimes problems, there may be problems with the version of the development environment for a specific project, and much more. This raises the threshold for working with this engine and forces you to spend more time on the investigation than necessary. Also, when installing, you need to select the correct version of the engine, since new versions of the engine do not support some old versions of Delphi. Usually, the description indicates which version of the development environment the selected version of the game engine supports. Next, I propose to look at some of the projects created on this engine.
I will be your instructor for basic training qualification. I suppose you've already reviewed the controls, enabled the joystick option.
Despite a number of shortcomings, this engine is still excellent for use in training, since 3D scenes and objects are easy to create and edit. Some things can be done without programming or with a minimum of lines. Also, this engine may well be suitable for the role of the first 3D engine, since the simplicity of the Visual 3D editor will allow you to immediately see many of the changes made in it. You can, of course, use this engine for large commercial game projects, but the complexity of installing and configuring the engine, as well as the lack of some game features, can discourage developers from using it. And if you ask the developers questions about the engine, you can wait a very long time for an answer. However, GLScene is one of the best among Pascal-oriented engines. That's all for me. The necessary links can be found in the description under the video. Thanks for watching. If this video was useful to you, do not forget to put your thumbs up or down. Subscribe to the channel, put a bell to learn about the release of new videos, and also write a comment. This will help in promoting this channel. Vitaly Sokolov was with you. See you in the next videos.